Hello everyone, my name is Petr Brantalík. I'm a senior front-end engineer at SDRV, where I have been focusing on React Native development for over 2 years now. And today I will be talking about Rive. The presentation will have two parts. First, I will briefly introduce what Rive is, what it can do, who is using it and where. In the second one, we will prepare an animation in the Rive editor, and then we will implement it in the React Native app. So let's begin. First, what is Rive? Rive is an animating tool allowing you to create interactive animation and changing their states and behavior based on the user input. But before we dive into what Rive can do, let's first look at who is using it and where. Rive has many use cases. You can use it for games, for example, for character animations. In mobile and web development, you can create interactive UI components or screens, or you can just use it for a prototyping before the actual development starts. Here is a list of some popular brands that already use Rive. Among them, as you can see, is Pepsi, Figma, Google, and others. The biggest partner right now is Duolingo. Duolingo has recently migrated all their animations to Rive. They have also released many articles and videos about it. Rive has a vast community. They have thousands of active users globally. On their websites, they have forums, tutorials, and something called share projects, where the users can share their creations with each other. That brings us to why use Rive. First of all, it's easy to use. All you need to do is download the Rive editor, create your animation, export it, and use it in your app. Rive editor is really intuitive, especially if you have some experience with tools like Figma, or there is also great documentation and plenty of videos or tutorials available to help you get started. Rive supports cross-platform integration, meaning design once, run it anywhere. Not only you can use it with React and React Native, you can also use it for native development with Swift or Kotlin. Or you can even use it in game engines like Unity or Unreal. Rive fosters collaboration between designers and developers. So if your designer is already using a tool like Figma, you can reuse all those designs with Rive. It supports types such as SVGs, images, audio, fonts, and even LaTeX files. As mentioned before, with Rive, you can create interactive animations, and no coding is needed if you don't want to. In both examples, the animation reacts based on the user input. Rive also allows you to run animations without compromising the app's performance. For example, compared to LaTeX, just in this Rocket example, the file size is 10 times smaller. Or in our app example, we run multiple animations on one screen without losing a single frame. And there is much more. With responsive layouts, you can create adaptable designs that fit any screens. Dynamic assets and text allows you to change assets in the runtime, while meshes bring organic and lifelike deformations to your images. Rive also prioritizes accessibility, ensuring inclusive experience. Then the paid plan adds more value with real-time team collaboration, revision history, which is similar to Git, we know, and the access to the newest features. But what are the key features for us, the developers? First of them is state machine. State machine is an environment where you can manage all your animations without coding. You can also add states, trigger events, etc. In the left example, the state machine triggers a certain animation based on which star is pressed. In the right one, the animation starts when the input state changes. What are input states? Input states are parameters that can be sent to the animation to trigger a certain behavior or change state. It supports types such as booleans, numbers, and triggers. For example, with booleans, you can toggle animation states, is playing, is visible. With numbers, you can control or modify the speed or the progress of the animation. Then with triggers, you can trigger a certain state changes, for example, open, close, etc. The next one are listeners. Listeners are similar to events in web development. They support types such as, or action types such as pointer down, pointer up, pointer enter, pointer exit, mouse move and click. They are applied directly in the Rive editor. And again, you can trigger a certain event with them, or you can even change the input states. Of course, not all of them are supported on each platform. For example, in mobile development, we have only pointer down, maybe pointer up, but I haven't tried that one yet. The last one are events. Events are signals that allows the app to listen for and respond to specific points in the animation. They are created in the Rive editor, and they can be triggered when a certain event occurs, such as when animation starts or when it ends, or you can even trigger them via listeners or in the state machine manually. The last slide is caveats. Although there are not many, I would want to still point them out. The first of them, and the biggest one, is related to React Native developers as myself who use Expo. Rive assets can be loaded in two ways. You can use network assets, host it on cloud, and load them via URL, or you can use local assets. However, for mobile apps, the local assets must be embedded in the native files. This is a bit issue for Expo users, as we recreate those native files on each build. Therefore, we have two options. First, we will go with network assets, but that can be affected by the network connection or by the file size itself. So you might need to add some additional loader that again can affect the whole user experience. Or you can go with libraries such as Expo Assets that allows you to use local assets without including them in the native files. But it hasn't worked on Android for me yet. I'm still working on that. The second one is related to types. The parameters that are sent to the animation and received from the animations are not actually type safe. Therefore, there is a lot of room for errors with typos. Lowercase I and capitalized in word idle in something I encountered while preparing this demo. And that concludes our theory part. Let's move to the demo. As demo, we will create this uploading screen. We have here our upload button. When the user click on it, it triggers the animation, the progress starts filling in, and it also updates our title. So let's open the Rive editor. Here we have our upload button. We are going to animate 3 states. First, we are going to animate stroke value for the progress circle. It's here. We can adjust the start value. It will start increasing, decreasing. Let's return it. Then we are going to also animate the stroke value for the arrow itself. Here we have vertical one and the horizontal one. So this is the initial state. And then the cloud itself. For cloud, we are going to animate 3 things: position, scale, and the fill itself. You cannot see it right now because fill is 0, but if I will increase it, you can see it. The fill itself is just a rectangle that is clipped against the cloud and serves as the filling. The cloud is scaled up. The reason is that the vertical line will serve as the base for the cloud later on. So you can actually see the vertical line. I had to scale it up. Then I will scale it later in the animation. So let's return it. And we can switch to our animation tab. Here on the left, can you see it? Yeah. We have our list of the animations we are using, or they are called timelines. First, we have the idle state. Who don't know, the idle state is just initial state of the animation when nothing happens and where we want to always come back to. We mark all values we want to always to return to our initial state. Then we have our init animation. It's this one. Next one is end animation. And then we have our uploading. You cannot actually see, you can see nothing because the cloud is hidden. Let's show it. And now if I will start it, the cloud starts bouncing. Let's return. The next 3 are related to our progress. So we have 3 states. First, we have progress start. That means that progress is equal 0. You cannot see cloud. The circle itself is empty right now. The next one is progress finished. The cloud itself is filled and the progress beneath as well. The last one is cloud disappears and the circle keeps to be filled. So let's create our state machine. We will call it state machine. Here we have our graph or something like that, and or our environment. Here is our entry point. And when we start the animation, it starts from this. And now we can start moving our animations which we want to use in this layer. So first we are going to start with idle. Then we are going to move to our init animation. Then we are moving to our uploading state, our end one. And then we are coming back to the idle. But if I will start animation right now, you can see this like VR behavior. And that's it, thank you. The reason is that the animations actually doesn't know about each other until we will tell them to wait for some specific condition occurs or the previous animation finish actually. So let's create those conditions. For that, we are going to create the input states. First one will be Boolean. It will be uploading state, which will be basically if upload starts or not. Then we have our progress, which will be number, progress. So we can start adding them here. So we want to add uploading condition between undo and init animation. So we will do it here, condition uploading true. Then between init animation and uploading, we want to actually wait till the init animation ends. We will do it here that we set exit time as 100%. Then between uploading and end animation, we want to listen our progress value and we want to move to this state only when the progress is equal 100 or it's bigger. Depends on the app. And then we have our end animation to idle. We can add condition that, no, we want to actually just wait till it finish. So here, and we can do some duration. So now when I will start, nothing happens till I will press uploading. It triggers our animation, start bouncing. I will start increasing progress. We haven't done that yet, but once it equals 100, then it moves to the end and return to the idle. Yeah, it will keep looping because we need to add additional condition that we want to start actually only when progress is less than 100. Now it should be okay. So we created our state machine for the uploading, but now we can also add for the progress itself. We must do it in the separate layer because you can handle only one event per layer. So if you want to change multiple animation or multiple states simultaneously, you must to create another layer. So let's call this layer upload Rive. And this will be progress. Okay, we have again our entry point. We are going to start with progress start. And then we will create something called blend state that helps us to actually, or blend state, what it does is that it can change the transition between two or multiple animations based on the user input. We can do it that we will be listening for our progress, and as the timelines, we will select our progress start and progress finish. And progress finish will be actually equal 100. And then we want to move to our progress end, and that should be when the condition is also bigger than 100 or equal. And then we are returning back when uploading is false. Actually, here we want to trigger this only when the uploading is true. We can also do back. For some reason, it will fail. Uploading false. So now, when I will start the animation, I will trigger our uploading state and start increasing. You can see we are updating the progress itself. And finishes and should return back. Yeah. So that's it. That's all regarding our animation. Now what remains is to trigger actually the state. You have two options. Either you can just use it as it is, and then you can wrap it in some component in your app and trigger the animation itself by ref. Or you can use listener, which we can apply here in the Rive editor, and trigger it when the action occurs. So to do so, we can create our touchable area around. We can call it touchable area. We will make it invisible. And then we will create our listener. Yeah, our target will be touchable. We want to trigger it on pointer down, and the value will be uploading, and it will change to true. So now, if I will start the animation and I actually click on it, it triggers it. Okay, that's all. All what remains is actually just export it. I have already done that, so we can move to our app. So I will change imports here. So now we have our uploading screen without the button. Here is our uploading screen. There is just some wrappers, progress title that we are sending the progress value there, and it's uploading it just Boolean. Then we have our use upload hook. We are loading the asset itself via use expo assets library. Then we have our states for is uploading and progress. And then we declared ref, so we can actually communicate with the animation itself. Then we have two functions. First is start uploading. We just simulate the uploading behavior here. And the step uploading where we want to return everything to the initial state. So let's start by importing the Rive component. Rive from Rive React Native. Let's load our animation and let's pass our ref. Okay, you can see button is already there, and if I will press, it already triggers the animation, but nothing has changed because we are not communicating yet between the animation and the app. To do so, we can start listening the state. We are getting two parameters from this function. First is the name of the state machine. We don't care about that one because we have only one state machine. We care about the other value, which is the name of the animation which is running right now. So we can state name. And we can find these names here in our state machine, actually. It's here. So we know that we want to trigger the uploading when uploading animation is running. So if state name is equal uploading, we want to start uploading. No. Now. So when I will press, we should start updating the title value. Now also we can add when the state name. Here we want to stop uploading when we are at idle state. So we can again use the name idle and void. I don't think it's okay. Okay. Now what remains to do is actually send those values to our animations so we can update it. We can do it in our hook. Here, where we are setting the progress, we can use Rive ref current set input state. First, we need to tell the name on our state machine, which is state machine. Then the state input's name, which is a progress, and the value itself. And in our stop uploading, we want to again use ref current set input state, state machine, progress will be 0. And we want to also set uploading state back to false. Set inputs, state machine, idle, and false. And that's it. When we restart it, I will press the button, it triggers the animation. We are updating both the animation, the value of the title and the animation itself. It finishes. And that's it. And that concludes our demo part, and I want to say thank you.